If x root 1 plus y into square root of 1 plus x equals to 0, then prove that dy by dx equals to minus 1 by 1 plus x whole square. So, related to differentiation calculus, let's go ahead and solve this problem. So, let's take y into root 1 plus x to right hand side. Then let us square it on both sides, because if you have square roots, then differentiation becomes a little bit complicated. So when we square it on both sides, we'll have x square into 1 plus y equals to y square into 1 plus x. Let us open the brackets and see, can we factorize this or not. We have x square plus x square y equals to y square plus xy square. Let us bring the y square to left hand side. So we have x square minus y square equals to xy square minus x square y. Can we write the left hand side as x plus y into x minus y? Then I see that I can take xy common in the right hand side. So I can take xy into y minus x. We know x minus y or y minus x, they both are negatives. That means if you cancel them, you get only minus 1. So we have now x minus y, if I take it as common, we have x plus y into x minus y equals to minus of xy into x minus y. Now certainly we know x is not equal to y, so x minus y is not equals to 0. So we can cut it off. We get x plus y plus xy equals to 0. Because x is not equals to y. If x equals to y, then dy by dx is 1. But what we need to prove is minus 1 by 1 plus x whole square. So let us take this equation now. This is going to help us to solve the problem. That is x plus xy equals to 0. Two things we can do. One, we can differentiate this and find out dy by dx. And second thing, we can also get y in terms of x. First, let's find out what is y in terms of x. So we can write down x plus y into 1 plus x is 0, or y into 1 plus x equals to minus x, or y equals to minus x divided by 1 plus x. Why are we doing this? Because our dy by dx should not have any y term. So in future, when I'm solving dy by dx, I get any y term, then I'll replace that with minus x by 1 plus x. Now let's go to the equation we got earlier, x plus xy equals to 0. Let us differentiate this. X derivative is 1, so I can write down differentiating. X derivative is 1 and y derivative is dy by dx. I'll write it as y1 plus x into y. This is uv product formula. So x into derivative of y, that is xy1, plus y into derivative of x, that is y into 1, equals to 0. Derivative of 0 is 0. Now can we take y1 common here, and we can write down, just explaining there how we did uv formula on xy. Uv formula product rule says that first function into derivative of second function plus second function into derivative of first function. That's a product rule. So now we can take y1 common and try to find out y1 in terms of y and x. Then we go back to y and substitute that whatever we got earlier minus x by 1 plus x. So we have now 1 plus y plus y1 into 1 plus x equals to 0. Or can I say that y1 into 1 plus x is minus of 1 plus y? Or y1 equals to 1 minus of 1 plus y divided by 1 plus x. Now the last step, what we have to do is substitute y in terms of x and we get our answer. So let's understand, we know y equals to minus x by 1 plus x. Then what is 1 plus y? Now let's write down y1 equals to minus of 1 plus y, but y is minus x by 1 plus x divided by 1 plus x. Let us simplify this. We will have minus of 1 plus x minus x divided by 1 plus x, that is 1 by 1 plus x divided by 1 plus x. which is nothing but minus of 1 by 1 plus x whole square. So, if x into square root of 1 plus y into square root of 1 plus x equals to 0, then dy by dx is minus of 1 by 1 plus x whole square. Now, what's the important thing you have to remember when we solve this type of problems is try to remove the square roots as much as possible. Then see anything you can take common which will simplify the equation. So we took x minus y as common because x cannot be equal to y. Then we got the equation x plus xy equals to 0. That helped us to get y in terms of x, not only that, to get dy by dx value in terms of x.